Hello, this is the many core programming project. This is group 8, composed by 2 people, and this is the report for Milestone 2. Here, as you can see, we have different profiling scenarios done with different picture sizes. The first scenario is with 0.5 megapixel to 2 megapixel, which we can see the different functions that consume most of the time, what's called hotspots. Here we can see GD image get through color pixel and puzzle fill, average light gray light scale, and other library function. In the scenario 2, here we compare 2 megapixel against 5 megapixel picture. Again, we see that the most time consuming function is GD image get through color pixel, and also some other functions that are in the puzzle fill debug from file. At the third scenario, we have big picture size compared, and here we can see again GD image get through color pixel and auto crop view. Those are the two most consuming time consuming functions. The strategy of parallelizing the algorithm is based on profiling and analysis of the code, which gave us 3 main functions to parallelize. Function puzzle vector sub, the first one. Function puzzle get view from GD image, and puzzle fill average light gray light scale. We did the parallelization of those 3 functions basically on the loops with the silk for statement. The natural focus is on the scalability, and in order to achieve much more scalability, we have to increase the number of tasks that are done in parallel, and based on this strategy we'll be able to achieve more and more scalability in our solution. We show 3 levels of scalability. The first one is with different picture size. Here we have profiling comparison between small picture size against medium picture size. Here, as it can be seen, a profiling where medium picture size has a lapse time 1.9 seconds and CPU time 3.3, and small picture size have lapse time 1.07 and CPU time 1.5 seconds. Here we can see the difference between CPU and elapsed time shows the amount of parallelism that we have. So here in the small picture size we have a difference of 0.5 at most, and here we have a difference of more than 1 second. If we go on and make another comparison, big picture versus medium picture, here we can show that big picture we have variability between CPU time and elapsed time of actually less than 3 seconds, and here, as we said before, 1 second. So if we increase the picture size, we have a more winning strategy from our scalable solution. The second level of scalability between different number of follows in the dataset. We had some tests with 3 databases of pictures with 2000, 4000 and 8000 photos, and here we have execution time and CPU time for the three basic profiling. Here we can see the difference is increased as we increase the data set of picture size, which shows a more scalable solution is achieved if we increase the number of and the third level of scalability, if we have a bigger CPU. We did two tests with CPU with 4 cores and CPU with 2 cores. In the 4-core result we have a lapse time of 32 seconds. In the 2-core we have a lapse time of 36.5 seconds. Here we can see that we achieve more in the case of 4-core result, and which shows us that we are on the good road to achieve a solution. Execution of the application. Here we demonstrate execution with 3 arguments. We explore the option -O for printing the results into a file, and we compare a picture with a data set of images. Here we have different results, the start distance values of our reference picture from the picture in the database, the 10 most relevant pictures that are similar to the one of reference, and the only one picture that's identical or close. Here we have another execution with a different picture set. Here we have the 10 most similar picture to our reference, and here we have the 4 identical picture which have the distance 0. In our next work we try to explore different amount of parallelism in the code by analyzing and trying to make use of runtime system by increasing the number of tasks to be run in parallel. We will do a more deep analysis of the function in order to see if it's possible for other functions to explore more parallelism. Naturally, this will be done with the tools that are available, like silkscreen to detect data races condition, and silkview to detect the level of parallelism. The solution will be tested on different architectures. Basically, we'll be unzipping the solution and rebuilding on the Visual Basic of the target architecture, and then execute the application with different picture sets and do some profiling of the